Okay, awesome. Yeah, so I'm going to talk about, I wish I had that, yeah. I'm going to talk a little about a project that I've done recently. I started a few weeks ago and sort of been on and offing, and just got to a semi-completed stage last night, in so much as these things are ever completed, you know. So little outline of what the talk is going to look like. So got 10 minutes of questions at the end, and 20 minutes going to give a little intro to the project, and then talk about the electronics, the circuit and the PCB design, and then the case design and the 3D printing, and then the code and what I wrote and stuff like that, and then some other bits at the end to tidy up. So the project itself is quite simple, at least simple enough to describe. I have an LED strip I installed behind the headboard of my bed as a kind of, you've seen these in hotels, you know, nice way for soft lighting. The strip itself is nothing special, just off AliExpress, but it's kind of, it's a nice way to light the room without ever having to actually look at the bulb or anything. So it just runs on 12 volts, pretty simple system. And the strip length that there is there needs about 1.3 amps. So I wanted to find a way to make this dimmable, you know, with ideally locally with a knob, programmable, so that I could say, for example, hey, I'm waking up at 7:30 tomorrow. Can you fade up from, you know, 0 to 100% from 7 to 7:30 in the morning, so it's nice and bright when my alarm goes off. And remotely controllable kind of comes along with that as well, so that I can turn it off and on, you know, my phone or whatever. So I have a Raspberry Pi Zero W in my bedroom anyway, or I did, or floating around anyway. So I thought I'll write the software for that, and I'll build up the system. So circuit board design is simple in principle. It all revolves around a MOSFET, just to turn on and off. I use an IRL Z44N and a MOSFET driver. I use that MOSFET because I've got a bunch of like 8 different types that I sort of, you know, shotgun bought off AliExpress based on 10 different forums, which all recommended different things when I sort of first started getting into switching electronics. And this is the one that's just always worked perfectly. It's got more than enough current headroom, and seems to behave beautifully with low voltages switching. Now, in fact, I do all my switching with 12 volts in this, but you know, it does also work lower. So why a MOSFET driver? Well, even with this MOSFET, I've had issues before pushing with a Pi GPIO pin. That the output is not a lot. I mean, a couple of milliamps, right? So if you're doing PWM frequencies, I found some instability because the capacitance on the gate is enough that things, you know, you really are pushing it if you're trying to switch very quickly. So I also put a driver on there. Now it's definitely over-engineered. In fact, the driver itself can source, I think, 1.5 amps. So in theory, would be enough on its own for the project. But you know, nice to do these things properly, I suppose. So the circuit is sort of in 2 halves. There's the half which is the half shown here, which just has the driver, which is the IC on the left, and the MOSFET on the right. Pretty simple. And then there's a switch marked as PWM switch on there. I don't know if you can see my mouse. Can you?
Yeah.
You can. Okay, so this switch here, which switches either the input comes from some external header pins which are connected to the Pi, or they come from somewhere else. The somewhere else being this second part here, which is a PWM signal generator. So this circuit uses a 555 timer in this configuration. So there's also one on board. The reason for this is that manual knob method I wanted to have as well. So if I throw the switch, it's controlled by the Pi and all the software. And if I throw the switch again, I can just use the knob to control it, just like any other set of dumb lights. So it's constant frequency PWM, and the potentiometer varies the duty cycle, so it fades beautifully, works perfectly, and not have any issues with that. Briefly, I mentioned on the previous slides, there is a slight flaw with this. So one of the features I put in was also a master on-off switch, which you can see just here. So this is the power coming in. This is supposed to be a DC jack. Don't ask me why the shape's so funny. And there's a master switch here. A small flaw was to channel the power through the master switch. It means that now I need a switch rated for, you know, some current. It's not the end of the world, but I had sort of envisaged just a little slider switch that I had, which is rated to like 300 milliamps. So I ended up just soldering this in the open position because no one wants to burn their fingers or burn something down with that. So then PCB design. So I did all of this in Eagle, Autodesk Eagle, and I really recommend it. It's free and has all the features I need as someone with absolutely no training in electronics engineering or anything. So I'm sure an expert would know why Altium or whatever else is better, but this is perfect. The other reason it's fantastic, which I'll come on to in a moment, is that it integrates directly with Fusion 360, which is, me as a hobbyist, my favorite design software because it's free and does everything I need for 3D design and 3D printing.
You like free?
We like free, exactly. That's the spirit. So yeah, there's nothing particularly. I mean, it was kind of interesting to me to learn because this is the first, by far the most complex circuit board I've ever designed. Only about the second or third I've ever designed, and the others were pretty much nothings. But wide traces where I'm sending power. Didn't have to be too picky about keeping things compact here because there was plenty of space, not too many components on. Used big ground planes and put lots of wires around for heat. Now, in fact, heat is not a problem at all with this circuit because it is over-engineered. But as long as, of course, you don't put a 300 milliamp rated switch as the master switch. All the I/O is on one side. That's the left side here. You can see, and of course, you can see there that that's the final made-up version. So JLC PCB turned it around very quickly and dirt cheap. So also favorite. If free is not available, then cheap is definitely preferred. I would probably use a SMD 555. The only reason I used a through-hole one is that I had a bunch. So that was basically free because I've already got like 60. But it's big and clumsy and more annoying to solder and puts metal on the underside and stuff like that. So I'll probably just do SMD next time. So then case design, and this is where Eagle and Fusion 360 come into their own because pretty much all of these 3D packages were already existing with the libraries that I used, like for the 555 and the header pins and the capacitors and all that kind of stuff. I did, though, have to make a 3D model for the DC jack and a rather rubbish one for the screw terminal block that I used here. But I could easily make them in Fusion 360 just with a pair of calipers on and the real thing in my hands, and then add them to the library part in Eagle. And then from Eagle, I can just click export to Fusion and it puts everything across beautifully here. So I have the PCB there as a 3D model in Fusion, which is great because it means I can just straight away build a case around it. And to do that, import all the components, put them where you want them, build a box around it generally. And then shell the box, round the edges, all that kind of nicety. And then add I/O holes. So that's nice and simple because I've already modeled all the I/O things. There's a 3D model for them. I can literally just say, well, there's the DC jack, extrude it on or extract it onto that face, widen it a little bit, and it's done. And then split the lid, just split it with a plane, add a registration ridge. So a little ridge that's inverted on each side so that they kind of fit together nicely. And then 3 clips, which are not on this because this is an old render. But I can possibly at the end I can show the most up-to-date one and actually give it a twirl so it makes more sense. There is a slight flaw in the design, which is annoying. I finished it very quickly yesterday and printed the thing off, and I had the idea before I actually came to do it the right way, but I ended up rushing and forgetting, which is there are 2 screw holes in the base to connect this to well, in my case I screwed it into the side of my bed, right? It would have been a lot better if they were a screw and slot design so that I could put the screws in and then slot it on after. As it is, I just made them screw holes, which of course means that the first thing you have to do when assembling is screw the thing to the bed, and then you have to muck around screwing in the PCB and all the annoying bits afterwards. So that's not ideal. So writing the code, and I'm actually a bit ahead of time, but that's okay. Writing the code should be the easy bit. I thought it was probably the bit I was most familiar with. And how hard can it be, right? You just listen on MQTT. If a message comes through that says on, you turn it on, done. The problem is that I wanted to do obviously a lot more than that. And it sounds simple. I'll just program it for tomorrow morning's alarm. You end up thinking, there's actually a lot of logic and sort of subtlety here. We have to think about, okay, well, I've got 10 alarms in and 2 of them clash. What do I do? I want to put in a repeating alarm. What do I do? How do I, I've got to have it fade up from a certain time to another time at a specific time as well. There's a little bit more subtlety to it. And I also, of course, wanted it to be non-blocking. So similar to what Tony was saying earlier with his problem, I couldn't be listening constantly on the MQTT sort of line and then also executing things, and then it wouldn't respond while it was fading up or something like this. That wouldn't be any good. I want my lights to work. So I ended up, once I had some ideas for how to do it, I used a minimum viable product sort of approach. So smash out something that works and then think how to add on to it later. A little bit sort of extreme programming ideas, I suppose, except without actually bothering to do the things that are difficult and should be done in extreme programming, like unit tests. Python used for everything. And I did take advantage of objects to make things, a lot nicer to visualize and stay on top of what was going on in this particular case. So it uses MQTT, so Paho MQTT. I don't know if there's another client for Python, but that's the one I use and it's great. Multi-threading for sure, and the PyGPIO or PigPO. So I started the whole thing just by writing the interface document, sketching out, well, how do I want to actually, deal with them? If I'm sending MQTT commands, what do I want them to be? So I basically just drafted this. Now this is the one that's actually implemented at the moment, but I'm going to supersede soon with some additional functionality, and that's going to change the commands. But fundamentally, I wanted on and off to work instantly. Set 50 or something, should set the brightness to 50% or whatever you specify, and then fade immediately. Let's say I'm reading and falling asleep. Maybe I sometimes wake up in the middle of the night and the light's still on. You can do fade 0, 30 minutes or something, and it'll fade gradually down to 0 over 30 minutes or whatever you want to do. So the way I actually got stuck in on this, which was a little daunting, I guess, is an extreme programming kind of style. I wrote all the top level functions first. So I said, right, I'll have a main function that spins up the threads, and then this thread is just going to listen to the MQTT, and then when it gets a command, it's just going to call a function called run command, something like this, and didn't worry about the details. And as I went through and obviously wrote that stuff, the stuff that I knew, it taught me, and the way to do the actual code underneath occurred to me as I went along. So it was a nice way to do it, I think. Fundamentally, the code runs with 3 threads. So one just listens to, there's a command topic on the MQTT, which is hosted on my other Pi. There's a command topic there that you send commands to, and there's also a log topic that it sort of sends back. If you asked a question, it will send back the answer, or if it will send back a warning or whatever. So the MQTT topic will do things like, an on command has come through. So it calls whatever function needs to be called when an on command comes through, which is obviously just set brightness to 100. If you call an event, now I want to fade at from 0 to 100% over 30 minutes tomorrow morning at 7:30 a.m., then it will add that event to a queue of events. So that's where the second thread comes in. The second thread is just always watching the queue of events and asking the soonest event, hey, have you started yet? Hey, have you started yet? In fact, it just sits there and waits until the thing has started. So it's not using any unnecessary CPU either. So each event knows when it started because it's initialized with enough stuff that it needs to know about when it starts. It's initialized with a start time and a duration, and it has lots of other methods as well. And I'll talk briefly about that in a moment. So that second thread just watches those events, and once they're done, it says, hey, you active? Once an event says yes, it says, great. What brightness should you currently be? The event says 3, and it says, okay, set 3. And then it does that in a loop, right? And so the thing fades up nicely. And then the third thread consumes there's a queue for outgoing messages to the log file, and it just publishes them. So if any of the other threads decide, oh crap, we need to tell the user something, all they have to do is do messages out, which is a queue, .put, hey, you're an idiot, don't do that. And instantly the other thread will find it and say, oh, dispatch that message. So the thing is always completely responsive, instantly responsive. And I mean, instantly for this application, you certainly can't tell any delay ever. and is always doing all the things it needs to be doing, which is taking new commands, actually running the light stuff, and returning any answers or warnings. So with that done, underneath then, how does the thing do it? And I've briefly alluded to this already. So I put in an abstract base class, ABC, called light change event. I didn't have to do it this way. I started out with just a single type of event, a class called fade event, which just, it gets initialized with start brightness and end brightness and a start time. And that's really all it needs. Oh, also a unique ID, but that's a later addition. That's just so that later on I can list them and delete them, specific ones if I want to, stuff like that. But basically it has a start brightness and end brightness and a start time. And from that it can calculate and a duration. So from that, it knows its end time. It knows it can work out at any given point. You say there, it has functions that says that say things like, what should the brightness be right now? And you can either pass it a time, or if you don't pass it a time, it will assume you mean now, and it will use datetime.datetime.now to find it. Otherwise, it will just it will sit there, and you can ask it, are you active? Are you finished? Have you started? Those are all functions. So you can just instantly have in your calling code, if event dot is started or is active, set brightness event dot current brightness, and it's all nice and kind of readable and makes sense. They also have a couple of other important things. So one is a check. One is that they override Python's dunder methods to sort properly. So they sort by start time, which means when I put them all in a priority queue, that is a sorted queue, I don't even have to ever worry about looping through them to find the one that starts next or something. They're already sorted because the class itself sorts by start time, which is what I want. The next one to start should be at the front of the queue. Easy. They also have a method called overlaps. Again, extremely easy to do when in this class thing, you just have self other and you say, well, if the start time of either of them is between the start and finish times of the other, then they definitely overlap. So return true, otherwise false. And I use that to filter it out. So the logic is, if you order an event through the command line and it overlaps with an existing event, it will just boot out the old event. It deletes it. So you can't have these conflicts ever. And it will also mention to you on the log MQTT on the log topic, hey, I deleted this event, just so you know. Since then, I've added more subclasses than the fade event. So an instant light change event, you can see what that does, turn on fully at 7 o'clock or whatever. And also something that's in development at the moment, not finished, light change event sequence. So the idea being you could say something like, hey, tomorrow morning at 7:30, fade up from 0 to 100 over half an hour, and then hold for an hour if you're not interrupted. Because if you are interrupted, if you send an off command, it will delete that event anyway. Hold for an hour and then turn off. So, just in case you're away or something you forget, most alarm clocks have this feature, right? They won't play the radio all day once they've gone off, they'll stop after an hour or something. Or maybe you want it to do something else. And then all the command functions just live in a dictionary. So when I get the command in, the command thread listens. It says, oh, I've got a command. All it does is pass that command directly to a dictionary of commands to call. And if the keyword, the first word of the command, exists in the dictionary, it runs the function that's the value in the dictionary. And if it's not there, of course, it raises an index error, and then I catch that and I pass back, hey, on the log thread, I pass back something to the user saying, hey, that's an invalid command. The source is on GitLab. I made it public a short while ago, and I'm more than happy to talk about it in detail. Obviously, I haven't got it up here just because of time, but I'm more than happy to do that for individuals or collectively if you want. So do go on there, suggest features. There's everything I've thought of and found is tracked in the issues. Ask me questions about the hows and whys and tell me why I've done something wrong, which almost certainly I have. But yeah, I'll have a link for it in a moment. Integration installation. So this was last night's work. I printed this yesterday evening and got home, and it finished at like 10:15, I think, the case. And it's the first time I printed the case, so I was not expecting it to work first time, but actually it worked really nicely. So you got a couple of photos there of the up-to-date case. You can see there's a just about C around here, the registration ridge that I mentioned around here and around here. That means they just naturally fit together and sit nice and flush. And then these clips here, so 1, 2, 3, that just means once it's together, they snap in place. They've got a little bit of kind of overlap so that they just sort of sit in and holds it on nicely. This is a panel mount potentiometer, and that just screws into the case. And then there's also this switch. In the previous renders, there were two switches. Like I said, I got rid of the master power switch because of the current issues. So this switch just says whether you're using the onboard 555, and so the dimmer knob, or whether you're using the software to control it. And there it is installed on the side, and it works perfectly. Apart from the mounting holes and the fact that I made a tiny error so that the PCB sits a little bit higher than it should, but it wasn't, I could just about squeeze to the IO. They weren't perfectly aligned, but they were fine. So to actually run this now sort of day to day, I use there's an Android app, which is very good, called MQTT Dash. It's free, I recommend it. So I use that. It does mean I have to type in the commands manually, which is less of a problem once I do new features, which I'll talk about in a moment, for like scheduling every weekday or something, so I don't have to program it every night. But you know, sometimes you just want a button, right? So maybe at some point there'll be an Android app if I can be bothered / learn how to write Android apps. So a quick rundown of tools I use and find good. So I've already mentioned Autodesk Eagle and Fusion 360. They're great together. My slicer for 3D printing, I use Cura. I have an Ender 3 V2, so it works. I run Octoprint on my other Pi, which is really good for 3D printing. I think most people who print probably have encountered that. Python development, PyCharm, just hands down. VS Code is also extremely good. PyCharm Community Edition is superb. I happen to have Pro Edition through work, but the beauty of all the development, like I never have to unplug my Pi from the other room to develop on it here with a full IDE. I just have a remote deployment, you know, so I code on it exactly as if it's running on my own computer, and it all updates the files remotely, runs it, does whatever you want. It's brilliant. So I very strongly recommend PyCharm, and I use CLion as well, which is JetBrains 2. For SSHing, I use Windows Subsystem for Linux, and also I dual boot and have my laptops have Ubuntu, so Linux is great. And of course, Git for everything. There was a time when I attempted project, but this project just wouldn't be possible while remaining sane, I don't think, without good version control. So for the future, like I say, it's public repository, so I really do welcome any input. That is the address of the repository if you want to have a look, and there's also a couple other public projects, including the one that I think might be of interest to you, the C++ state machine that I wrote, which is on there, Slow Cooker. There are a load, and that's also where I keep track of bugs and features. There are quite a few in there at the moment, including these. So there's 5 particular features, 2 of which I'm working on. So cron style repeat events planned, so you can send a command and say, you know, just in the normal, everyone knows cron kind of formatting, right? You know, how minute of hour, hour of day, day of week, day of month, you know, you can choose things to repeat according to whatever pattern. So there is a library to handle that stuff in Python called Croniter that I intend to use. So that's something that I'm putting in now, but it's, like I mentioned before, has quite a lot of complexity. You don't necessarily want to create infinite events forever. So Croniter is an iterator, but then you've got to think about checking for conflicts with future events. You know, how do you make sure it doesn't, the one you just put in doesn't clash with the 50th run of this Croniter, stuff like that. Light change sequences I already mentioned, that's under development. Holiday mode, pretty much that. Suspend for a while, that should be fairly easy. Burglar mode, do some random light dances to look like somebody's in, and like I say, possibly an app. But I'm very much open to ideas and input. Like I say, it's a public repository, so I think anyone can add an issue on there. If you think of something or want to ask a question, you can get in touch that way. And finally, something I started doing a few months ago, I did set up a website where I kind of record some of the stuff that I do in these personal projects. I have what else is on there? I think there's a little bit on there about that Slow Cooker project. I also have a benchtop power supply because we like free, right? Which so I pretend it's free even though it cost me about 50 quid in PLA. So it's an old computer power supply rated like 450 watts, more than you could ever want, and a cheap sort of, you know, adjustable voltage current doodad off AliExpress, combined with a load of 3D printed stuff. So there's a little bit of information about that. You can also get in touch with me if you want to tell me why I'm an idiot or ask a question about a project or whatever it is. So yeah, it's at peterrhodes.info, and there's links to my GitLab there too. So I have gone over there by about 5 minutes, but any questions? I haven't been keeping up with the chat, but I've seen there's been some things. Does it wake you up? Autodesk has bought Eagle, so it's no longer free. Yeah, I know it's Eagle Autodesk, but I don't pay for it. I'm pretty sure they have a free tier. Well, I hope so, because otherwise I got it somehow. I've definitely never paid a cent for it. Yeah, 2 schematic sheets, 2 signal layers, fine. I mean, yeah, okay. Okay, that's interesting. I didn't know that, but I mean, that for me, 80 square centimeters and 2 signal layers is enough. So yeah, I can see it might not be if you want more. Does it wake you up? Would it work for someone who's hard of hearing? Yeah, I guess. It doesn't, I wouldn't say it wakes me up, but then I don't have the best curtains and I live in the UK, so I suppose already got used to not waking up just because of the light. But it's kind of nice. I think it helps at some level. My brain started to wake up a bit before Zoe Ball starts talking at me. You know, so it probably does help. I just find it a bit nicer to wake up in the light. It doesn't really matter in summer, let's face it, but in winter it'll be more appreciated. What do you use for your 12 volt supply? Well, right now, a cheap AliExpress 12 volt supply rated at 1.5 amps doesn't get too hot when I put 1.3 through it. Should be fine. I do have some proper ones out of the wee bin at work, rated at 5 amps, but I've yet to use that. Yeah.
What if you deal with the what if you deal with the nonlinear nature of the LEDs?
That's a really good question, and one I forgot to put in here. Excellent. I use CIE 1931. It's just a function in there. So only the set brightness. So that's a conversion, if you don't know, between apparent brightness and true brightness. So yeah, if you put the LEDs on 50% of the time, so 50% duty cycle, they look like 90% as bright as full, and so on. So you want to kind of deal with that. So yeah, I have a function in there that just when set brightness, I actually pre-computed it into a lookup table rather than have a function that does the computation every time. So I have a lookup table I pre-computed that just has the percentages 0 to 100, and then their corresponding what the duty cycle should be. So for 50% brightness, it's actually only like 18 or 19% duty cycle. So it's very non-linear. But yeah, that's just done at the very last. There's only one function. The beauty of all this, the way it structures, is there's only one function that ever actually calls, affects the pin, does the output. So all the stuff in terms of recording what the current brightness is, which is occasionally useful, and doing that conversion is only ever in one place. There's no duplication. Perhaps add a PIR sensor to switch on if the room is dark when you enter the room. Yeah, it's a great idea, but it is a bedroom. So I don't want to roll over in the night and get my retinas redone. But yeah, it's true that doing that, certainly for if you had it in a bathroom or something like that, that would be a really nice thing to do. Another feature I've thought about is a default fade up. So if I wanted it to do, when I send it on, I don't want it just to come on. Maybe I want it to fade up, like some of these fancy lights do over a second. That would be an option, or indeed non-linear fades as well. I've thought about, so maybe a sigmoid fade looks maybe a little bit more natural than a straight ramp. Are the Gerbers on GitHub? Not strictly the Gerbers, no. The board, so that the PCB design schematic is on GitHub, but that is through Eagle, so it should open fine through there. Like I say, the free version is certainly enough for this board, so it should open fine. But if you message me to request that, then I can probably put the Gerbers on there. It should be fine. You thought about using Node-RED for vacation sequence profiles, e.g. using the big timer extension? You can create a simple UI for use on the mobile easily. Now, Node-RED to me means microcontroller. Either I'm wrong about that, or it's something else, or I'm not understanding what you're saying. Who said that? Robert Link.
Yeah, as you have anyway some Pis running, it runs on a Pi permanently for my application, for example. And I use it for my Zigbee controlled lights very much. Yeah.
Well, one thing with Node-RED is it talks MQTT natively, so you could have it somewhere in the room, happily feeding appropriate MQTT commands
right
into your system. and
Right.
responding to things, and actually use it as basically a remote controller.
Sure.
Um,
Yeah, there's so much stuff you can do with it. I think now the basis is there. So an Android app is an option, but also, other things that automate it. As far as the holiday lighting, I've actually got, in fact, if you look in the GitHub issues, that holiday lighting is in there as a feature request. And I have, I think, 4 or 5 levels of increasing complexity. So one was literally random times it comes on and off, which obviously isn't very convincing. If it's flicking on and off at 3 in the morning. The next is random times, but weighted according to time of day. And then the maximum complexity, or the most silly one I thought of, is it actually records exactly what you did the week before, and then overlays it with weekdays and stuff as well on this one. I don't know if I'll ever bother to do any of them, but
But there's some nice features in this Big Timer plugin or extension of Node-RED, which is just doing like these things, or also taking care about your GPS location and then doing 1 hour after sunset or stuff like this. Yeah.
Right. Yeah. No, that's actually really nice. I'll have a look at Big Timer. Thank you for that. Certainly, one thing I'd think about is something like using, I don't know, maybe if this then that, or something I haven't done much with, so that I could say, okay, Google. I mean, my nearest one's in the kitchen, so I'm not certain why I'd want to turn on the lights in my bedroom from there. But so you can do it, I guess. And the principle means I could apply it later on somewhere else if I wanted. Different color light for workday and weekend. Yeah, I mean, this strip, I'm not super into the kind of RGB rave kind of thing for my bedroom. I mean, it has to be a date that's going particularly well, I think, to go into that kind of mode. So I just have the single strip that's just 2700 Kelvin, nice warm light. So I don't, but yeah, you totally could, right? You could keep the 2700 for the weekend, and in the weekday you have either another strip underneath or a adjustable CRI, which is basically the same deal, right? It's basically just 2 sets of LEDs and you address them. Might be wrong about that. I think that's how they work. Either or. I could put a cold white strip underneath and then fade, have them adjusted to mix differently. Yeah.
Well, LED strips, are they dot star or are they 2812?
Say again, sorry. Are they what?
What model LED strip are they? Are they the 2812?
Excellent question, to which I don't know the answer. They are. I can find a link for them. Probably dig out a link. They were either AliExpress or Banggood. They were like £12 for some number of meters.
I don't know. The dot star. There've been a few talks on this meetup on dot star. Are they always 5 volts or 12?
Not either, right? You're just feeding a PWM signal, right? You're not.
Oh yeah, sorry. If that's a control thing, then yeah, there's no control. That's the point. They're totally dumb. There is nothing on them at all except LEDs and resistors.
But you're still running a current. I mean, you're still running 12 volt into it, and then and then you got 2 signal wires, or because
no signal wire. It's got exactly 2 pins, and those you have to solder directly onto the tape or buy those clippy things. It has ground and 12 volt. That is it.
It's a fancy light bulb. It's nothing more.
Yeah, minus the fancy.
But it's programmable. You can still change each LED, or they. Oh, they're not. Oh, okay. Sorry.
It's a fancy light bulb.
That's what all the MOSFET stuff at the start is for.
Yeah, basically that's what the whole pointless project is for. It's one of those things where someone says, "Didn't you know you can buy one of those?" And I go, "Yeah, it would have been a lot cheaper to." No, it's all right, but that's not the point, right? So so it's a totally dumb strip. All of this is to control this, and the nice thing I guess is that you could use these same concepts, possibly in the same circuit board, to control pretty much anything dumb that you wanted.
Yeah, I use 2812 with 5 volts, and then I have it motion PR sensors that have MQTT, and then I use kind of a wild card subscriber. So if any of the sensors pick up movement front of the house, all the LEDs come on, that kind of thing.
Sure.
And then they graded depending on the time of the night or that sort of thing. Yeah, exactly.
Oh, nice. Yeah, that's cool.
And then the cameras work on a kind of also the kind of the wildcard subscribers as well. It works quite well.
No, that's cool. Let me quickly and please do carry on with the questions, because I'm not.
Yeah, it's going a bit off topic, but has anyone used Raspberry Pis with the NeoPixel devices? Because I sort of read that the timing issue causes a problem, but maybe some people have bypassed that.
You're talking about the normal 2812 strip.
Yes.
Yeah, I found it fun. The only thing that I found is if my from the Raspberry Pi to the actual NeoPixel, if it's more than about 2 meters, I need to use a level shifter. And as you know, they're like 30p or something. They cost nothing. But that's just to get it from 3.3 up to 5 volts. And I've besides that, I've got these strips all over the place, and no problems at all.
Yeah, I think the story with the timing is that when the Pi very first came out, it really wasn't able to generate, or people didn't have the software to generate the right protocols with the right timing accuracy. But what's happened in the intervening decade is the Pi has got better, and people have figured out how to use DMA and stuff like that to generate the right waveforms.
The only annoying thing I think is that I found is you can only run it off pin 18 or whatever it is. So
yeah,
if you're wanting to run multiple strips off one Raspberry Pi, you've got to kind of serialize them, and then your programming gets a lot more complicated. If you want to run multiple.
If I remember right, on the PWM there are 4 pins, but there's only 2 pairs of 2, and they're duplicated on the PWM, I think. But that's for hardware PWM. I haven't tried software. The reason I use Pi GPIO is I could use the hardware PWM and do it properly. But I think probably for a lot of applications, software PWM would work. But anyone else know that to be the case or not?
Yeah, there's while they talk about being PWM control, it's actually not. It's DMA.
Right. Okay.
And since there's 2 DMA you can redefine 2 pins on the GPIO for DMA. I think you can actually run 2 separate strings off of one Pi.
Right. Yeah, I think that's right, because there are 4 pins, but they're 2 pairs of true hardware PWM underneath.
Yeah, I did a presentation on this a couple of years ago on how to redefine using the how to redefine outputs. And because I do a lot with the general clock outputs.
Yeah.
So you just redefine the channel, the DMA channel that's coming out on.
Quickly, for people who are interested in this part of it, so the 3D design, this is the registration video I was talking about here. There's some tolerance offset that I define between this and the lid. So when the lid sits in, if I do an inspection here, close that. If I do an inspection by section and then go through, we can see how this sits. So you can see there's a small gap, just to make sure that once they're printed and you get errors and stuff, they still fit together nicely. That ridge just means that when you put it on top, it naturally finds its center really nicely. And then the clips, there are 3 clips on this one, and they just look like this in section. So they sit, and then there's just enough spring there. I think there's about 1 mil or half a mil or something of protrusion. It's just enough spring there. There's a resistance when you put it on, but then it goes on, and then it won't come off. And I mean, you could take it on and off with a bit of a squeeze. I wouldn't do it thousands of times because the way it's printed. But, this is a nice way to do things I've done with you.
Your registration ridge is stepped. When you're printing your own stuff, can you do something like that angled, or is 3DP really more suitable for the sort of raster style shapes that are in layers?
No, the reason it's stepped is to make it work, basically. I'd do the same even if I was injection molding. If it was, you mean if it was like a slope instead or something here?
No.
Oh, what do you mean, sorry?
Yes, I do, yes.
Oh, you do. Well, if it's a slope, then the lid will just happily slide off. You really want it to be that stepped effect. That's exactly what you want. And you'll find that if you have something with this kind of design, even in injection molded or professionally done, they will use this basic concept. You want it to be stepped so the thing sits inside and doesn't want to go out. Otherwise, a lateral force will cause it to slide up, which is kind of the problem you had in the first place that the ridge was trying to defeat. You can, for sure, you can round these edges if you're worried about them chipping or whatever, but generally it's okay. Who's running a 3D printer right now?
You mentioned the height of the PCB being slightly off.
Yeah, so this is because I'm a moron. So sorry, go on.
I haven't quite got that far yet. I'm using ABS boxes. Presumably you did in the past. What do you use for packing material? Because I find it really quite hard to come across. Yes. ready-made project boxes?
Oh no, I've never used one.
Oh, okay.
I got
if you don't mind me just throwing this open to the, if you don't mind me just throwing this open to the audience, as it were, when you want 2 or 3 or 4 millimeter packing to raise a PCB, does anyone have any recommendations, or do you all use standoffs? Okay, thanks.
Sorry, I can't help. I can show you how I did it in this one. The reason that these don't line up, you can see they line up beautifully in the model. But the reason they don't line up is that I stupidly, if we bring that section analysis back, you can actually see that the I just basically cocked up on this, so it's got an overlap between the PCB and the posts that they sit on. So of course in reality it sits this millimeter higher or something, but it wasn't enough that this doesn't work. So I managed just about to squeeze the things in anyway. But yeah, another touch I tend to add, it really is overkill for the I'm not taking this on and off all the time, but I did use yes, thank you. You can okay that, get rid of that. I did use heat set inserts. So these all have little brass inserts that I insert with a soldering iron. And then when the screws go in to hold this down, they're not screwing into plastic. So it's not like I can unscrew it in and out like 5 times before the whole thing's worn out. You know, you can do it forever, and it's professional and fits together. It's lovely. In answer to your question, if you haven't seen the chat, Anthony Mark says laser cut from 3 or 4 mil perspex, basically make a washer.
All right, Peter, we're gonna have to move on.
Thanks.
Thanks a lot. Really quite involved project. Was when you first gave us a description, it sounded quite simple, but actually there's a lot of stuff involved.
Yeah, I think I probably thought that then as well.
Great. So we'll take a short break, say 5 minutes, then we'll crack on.
Yeah, Richard, I'm going to message you a URL.
Okay.
Yeah, regarding the question about standoffs, if I had some standoffs to hand that were the right size, yes, that would be perfect. But probably I'd end up getting a plastic tube and cutting it into little lengths and try and get them the same length, and just use a small bolt and screw those to that depth.
Yeah, Nick, that's exactly what I've done. So Anthony, I very untidy method of doing it, but I had some old aquarium tubing, air tubing from a fish tank, and I cut the pipe and used hot glue and just raised the board up that way. Very very awkward, but it did the job. Once the lid's on, as long as it works. I'm not like Peter. It's he did a fabulous job, didn't he? A really professional job. But for me, as long as it works and stays in place, that's the way I've done it. It sounds as though you want something a bit more upmarket, though, a bit more professional than a 3 or 4 millimeter cut of aquarium tubing and hot glue.
It's not professionalism. I'm quite happy, but I find myself ransacking the garage looking for 2 millimeters when everything is 3 or 4, or vice versa. I tend to use slabs as instead of standoffs, because that way I don't need to leave a screw hole. And I suppose it's all my own fault. I'm basically run out of space. If I were to upsize the case in the first place on everything I do, I'd probably be all right.
I think I remember, if I admit to it, using a big biro and cutting that into 5 millimeter lengths.
So what's somebody 3D printing at the moment then? What's going on? What can we hear? Nobody's going to own up. Nobody's going to admit.
It's not me, I promise. I've also sent the Gerber files in the chat, as well as the links to that. So I can't remember who requested those, but you can have a look if you're interested.
Peter, the demo of using Fusion with the circuit board on there, it just looks really neat. I'm gonna have
Great.
to try that.
Honestly, it's great. Yeah, like I say, if there are any bits that you need the 3D model for that aren't in there, you can make it in Fusion, export it as a step file, import it to the library component. So for example, for that DC jack, I had the footprint, although I had to edit that because it wasn't quite right, but not the 3D model. I wanted the 3D model so that I could make the IO holes in the case and just know that it was right. So I did set about one of those with calipers, which is a bit slow. But then after that, everything is gravy.